This one is another improper integral, and it doesn't appear so at first because the first thing we look for with improper integrals is infinities here and here. But what you should know is that 1 over x squared has a vertical asymptote at x equals 0. That makes the bottom of this fraction 0. And since x equals 0 is between these two values, that means that I need to split this thing up into two integrals. So I'm going to split it up into the integral from minus 1 to 0 of 1 over x squared dx plus the integral from 0 to 1 of 1 over x squared dx. So to evaluate that out, I got to use limits for each of them. I need to use a limit for this part and for this part. So I'm going to do a limit as I'll start with a approaches infinity of, let me integrate this here. So if I integrate 1 over x squared, integral of that, well, I do power rule, I bump, because that's the same as, well, that's the same as x to the negative 2 integrated, which means I need to bump it up, which gives me x to the negative 1, which is 1 over x. And then I need a negative sign out front to deal with that coefficient being correct. So I'm looking for the limit as a approaches infinity of negative 1 over x evaluated from minus 1, that comes from here, to this guy, and that's my a, and I made a little mistake and I'll fix it, to a. So I wrote infinity when I should have written 0, because that's what I'm letting it go to. And then I need to add the limit as b approaches 0 of, same thing, minus 1 over x evaluated from b to 1. So from here, I just got to evaluate those limits. So I need to plug in or imagine looking at the limit as a approaches 0 of this thing, right? Why don't I draw a graph of 1 over x? So 1 over x looks like this. Actually, I've got negative 1 over x, so this is 1 over x. Negative 1 over x is going to be a flipped version of that. So I'm going to be like this, right? And as a approaches 0, and I should really have a approaches 0 from the left, and then as b approaches 0 from the right. So as 1 over x approaches 0 here, it goes up to infinity, right? So what I get is a infinity. And then as I plug in 1, I get minus a negative 1 over negative 1, which is going to overall be minus. And then that's the first part. And then I get plus. All right, when I'm plugging in 1 to this, I get a negative 1 over a 1. So I get negative 1 over a positive 1. And then minus is my minus from my integration. And now I need to look at the limit as b approaches 0, but from the right this side. And so the reason why I look at it from the right is because this is the integral of this thing on the right side of 0, from 0 to 1. The reason why I have this minus sign here is because this is the integral on the left side. So I'm looking at the area from minus 1 to 0, and I need to look at the left limit as we approach the area, per se, under this thing, instead of the right, because I'm coming in from the left. Here I'm starting on the right and then moving away from that x value of 0. So then I get, let's see, what do I get next? I want to plug in for b. I want to look at what happens to this thing as b approaches this from the right. So that's going to go down, which means it's negative infinity. So I wind up getting a double negative And then what I get is infinity minus 1 plus infinity, which is going to be infinity of some form, so therefore it is divergent. That's all.